Today we got a hard problem, maximum profit in job scheduling. We have n jobs where every job is scheduled to be done from start time to end time. Obtaining profit, you are given the start time, end time, profit, arrays, return maximum profit. You can take such that there are no two jobs in subset with overlapping time range. If you choose jobs that ends at time x, you will be able to start another job that starts at x. Okay. How many we got? Ooh, 5 times 10 to 4. Oh, that's quite a lot. Okay. Okay. Profit is 10 to 4, so max profit will be 5 times 10 to 8, so we fit in an integer. So what I'm thinking is that I saw this problem in an interview I did for IBM online assessment, I think, but instead of max profit you should just take max number of jobs without overlapping. And how I think I did the solution was with dynamic programming. You sort by ends and then you iterate over them, and you maintain DPI, which is max profit from first I, and then you do binary search to find the latest ending job, right? So either you don't take it and you take the previous one, so you take DPI is max DPI minus 1, or we take this and then DPJ, where J is maximum J such that the job ends at most here. And I think that's the answer here, so let's code it. R start, yeah, the same length, okay. So let's do it like this. So we'll have this P like permutation. And then we do end time. Can there be jobs with same like I guess it doesn't matter, so we only care about the ending. So end time x, end time y, so that's our sorting. So now we got the indices of the events. And then dp0 is profit, permutation 0, so we always have to index by the permutation. We return dp back, or like dpn minus 1 to make it readable, and with spaces because I don't like to not use them. And now we go like this, I1, I and I plus plus, and now dpi is dpi minus 1, and then we start binary search. And now if end time so end time of PM is larger than or equal to end time PI, then RM minus 1, right? Because no M, yeah, if it's larger than M minus 1, we bought some because we want something smaller than or equal to, else L is M, and in that case we have to do a plus 1 here. So there are two cases. You can always do binary search of this, right? R equals M minus 1 or L equals M plus 1, and in the other case, if you have m plus 1, then you don't put the plus 1 here, and otherwise you put the plus 1 here. Afterwards we also have to do one more check. So if end time PL is smaller than or equal to end time PI, then DPI max, DPI and DPL plus profit PI, and I think this should pass. No. Maybe I'm missing something. Let's see, how is their permutation? Okay. So let's, I guess let's show DP then. Oh, because, yeah, because not end time, but start time. Why are you probably already are shouting on me through the video. Oh. That's weird. Start time, end time, 564. Yeah, I think I should put like start time insert so the times are all 0. I'm not sure how insert works, to be honest. We need to put like a 0th element. Okay, so it works like that. And time profit. Profit. Okay. So that's, a reason why we are doing this is that, like, I don't know, I hope I explained it clearly. In no way I immediately got a solution which is not slow. Binary search plus dp o n log n intuition. Sort the intervals by their ends, then we can construct, then we need to construct the following construct dp, where dpi is maximum profit from first what was it, like jobs? Yeah, jobs. we can either skip the current job I, or take it and then ask what is the maximum profit from jobs that end at the latest when job I starts. Since we have the intervals sorted, by ending time, we can simply binary search for the largest j such that job j such that end time j is smaller than or equal to start time I. The answer is then dp and -1. Note, we get the start/end times and profit as 3 separate arrays, and which we can either make into an array of vectors of size 3, or, as I learned, use a neat trick I learned from watching Gennady Korotkevich. We can have a permutation of 0, 1, blah blah blah, and -1, which we will sort based on the end times, and that permutation is our order of events, and every time we want then we simply iterate over the permutation p and when and our current event index is pi instead of just I. O n log n. First sort the events by their end time and then iterate over all of them. Note, we cannot use sliding window as you might be tempted to do, since the indices j for increasing I are not non-decreasing, since start times since start times of events after sorting them by their end times are good will not necessarily be a non-decreasing sequence. And do a binary search for each of them of n, since we store the entire DP array in since we have to store the entire DP array. Okay. And we also store the permutation. And this minus looks bad, so since we have to store the permutation and the entire DP array update. So we cannot even use the O1 trick that we need only the last element, because the starts are not non-decreasing necessarily. So okay, I mean, I already saw this problem and I solved it then, so I could solve it now. This was same, but you also had profit, but that's like instead of +1 there is plus profit. So okay, goodbye.